Okay, let's get started with question 17 on the test 2 review. They're asking us to use our graphing utility to graph the function. So I would pick that calculator up. I would go to y equals. Notice the way I have that typed in. Well, let's see. Let me do that. Let me move it over here. I put the 1/5 in parentheses. Not sure if it was going to make a difference, but I wanted to have it there just in case. 1/5 x plus 2 squared, 2x minus 7 squared, and when we graph it, we get something like this. And if you notice where that graph is touching the x-axis, on the left side it looks like it's at -2, and on the right side it's a little bit past the 3. So -2 on the left, a little past 3 on the right. Let's find a graph. So looks like our graph, what did I do, matches with this one. I'm going to check one more time. -2 and a little bit past 3. There we go. So there is our graph, strictly calculator. So let's check out, oh, we're not done. I guess I should look ahead. Approximate the real zeros. Well, we can get those straight from this function because what's nice is it's already factored for us. So this factor would give me x equal -2 as a 0. This factor would give me x equals 7/2 as a 0. And because this factor has a degree of 2, this guy has multiplicity of 2. This guy has a degree of 2, so he has multiplicity of 2. So -2 and 7/2. So -2 would be the smaller value, and it has multiplicity that is, are we asking for even? Even, yes. And then the other one, which was 7/2, its multiplicity is even as well because it occurred twice. Okay, let's check out 18. Oh, the only thing we can do on this is basically just do the synthetic division. So let's recall how that gets set up. We've got our box. And since we're dividing by x plus 2, remember when it's in that form, we do the opposite sign. So in the box, we'd have a -2. Polynomial needs to be in descending powers, and it is. But since it skipped the x squared, I need to put a 0 in place for the x squared. So 6x cubed plus 0x squared plus 5x plus 7. And we're just going to drop that 6 and multiply. 6 times -2 is -12. Add that to 0, we get -12. -12 times -2 would be 24, plus 5 would be 29. And 29 times a -2 would be a -58. And if I add that to 7, I get a -51. So the quotient would be the polynomial 6x squared minus 12x plus 29, and the remainder would be -51. Okay, so we've got our quotient and our remainder. Let's check out our next question. Okay, question 19 asks us to use the remainder theorem and synthetic division to find function values. Now, you could certainly go to your g of x function, plug in a 2 everywhere you have an x, and find that function value. For each of these, we can go back to the old method. But I want to emphasize the remainder theorem here to show you how that works just as well. So if I want to find g of 2, in the box, I put in a 2. I don't change the sign. Then I mark my coefficients. Now we have some skipped terms here. The first one is x to the 6th. X to the 5th is missing. I have an x to the 4th. X to the 3rd is missing. I have an x squared. The power of x is missing. And then we have the value of 1, our constant. So you got to be careful to put in all those missing terms. Then we just start our process by dropping the 2 and doing our multiplications and additions. 2 times the 2 is a 4, plus 0 is 4. 2 times 4 is 8, plus 3 is 11. 2 times 11, 22, and so on till we get to the end and we have our remainder. And the remainder is 173. So this is called the remainder theorem because the answer you're looking for, the function value, is the remainder. So g of 2 is equal to 173. I could do that with the 1, the 3, and the -1 to find each of those function values. So again, emphasizing the remainder theorem. So let's check out question 20. We want to use synthetic division to show that we have a solution to an equation. Use that result to factor the polynomial completely, I should say, and then use that result to factor the polynomial completely. So we've got an equation. I know that this is a solution, which means if I divide using synthetic division, I should get a remainder of 0. Let's see if that happens. X cubed, missing the x square, -28 on the x, -48. Let's see what happens. Bring the 1 down, we get -4. Here we get 16. When I subtract those, I get a -12, and -12 times -4 is +48. So yes, we get a 0 remainder. That tells me that -4 is a solution. This result, the polynomial result here, is going to start with an x squared because the original was an x cubed. And when you divide it once, you lower that exponent by 1. So x squared minus 4x minus 12 is my resulting quadratic. And we know how to handle quadratics, either factor or use the quadratic formula. And I'm thinking this one's going to factor. Multiply to get 12 would be 6 and 2. And to get a -4 would be a -6 and a +2. So x minus 6 equals 0, x plus 2 equals 0. And so I get a 6 and a -2. Now, I would not have needed to do any of this if they didn't ask me to. Look back at the problem. It says to show that -4 is a solution. I did that with the remainder of 0. So I was done with that part. But then it said to use the result, there's the result, to factor the polynomial completely. So I used that result. It was quadratic. I factored the polynomial completely, which gives me 3 solutions. The -4, the 6, and the -2. So we want to list the solutions, comma separated lists. So I will start with the -4, then the 6, then the -2. So those would be all of our solutions. Okay, where did okay, what happened? So let's check out problem 21. We're given a function, it's a 4th degree function, and they're telling me that they are giving me 2 factors. And what do we know about factors? Factors bring about zeros. So if I have a factor of x plus 2, I know the 0 is x equal -2. A factor of x minus 4, I know the 0 is x equal to 4. So they want us to verify that those 2 guys are factors. So we're just going to do synthetic division, and the goal is to see if we get a remainder of 0. So when I do synthetic division with x plus 2, put a -2 in the box, we get a 0 remainder. Now notice they have it set up for us for x minus 4 to verify him. So we need to put the 4 in the box, do synthetic division, and show that we get a 0 remainder. What they didn't do for us is they didn't have us do repeated synthetic divisions. because neither one of these gave me a quadratic at the end so I could find the remaining factors. So yes, I did prove that those two are factors, but by not doing repeated synthetic division, I can't get at the other two. So I came on the side here and rewrote this first synthetic division, dividing by the -2, but now I'm going to start the other synthetic division off of this result. So now let's divide by 4 off of that synthetic division result so we can get it down to a quadratic. So I'm going to drop my 8. 8 times 4 is a 32, and when I add those two together, I get a 2. 4 times 2 is an 8. 8 minus 11 would be a 3, and a -3. And 4 times -3 would be a -12, and I get the remainder of 0. I knew that was going to happen, but the repeated synthetic division helps me because I'm left with a quadratic. 8x squared plus 2x minus 3. And since it told me to find the remaining factors, this thing should factor. Go ahead and factor it. So that quadratic factors into 4x plus 3 and 2x minus 1. Remember, you can always check your factoring by remultiplying that out. The way I got started on this factoring is I broke the 8x squared into a 4x times a 2x. That gave me an 8. I broke down the 3 into 3 times 1, and I put the 3 and the 1 in those positions because this gave me a 6x, and this gave me a -4x, and those add up to 2x, which is what I was looking for. Okay, so it wants me to find the remaining factors. I have my two factors there, so let me put, I'm assuming it just wants the 2 that I just found. So I'm going to type in 4x plus 3, comma, as one factor, and 2x minus 1 as the other factor. Now, I'm not sure if it wants me to have the parentheses or if it would want, want it listed as 4x plus 3, comma, 2x minus 1. Not real sure, but you may have to play with that. Now that I have all 4 factors, I can write this in completely factored form. I have the x plus the 2, the x minus the 4. Notice there's no comma between these. I'm not listing the factors, I'm writing it in factored form. So the x plus 2, x minus 4, the 4x plus 3, and the 2x minus 1. So that would be completely factored form. No commas between those. And then listing all the zeros, we have a -2 from the first factor, a 4 from the second factor, -3/4 from the third factor, and then 1/2 from the last factor. Finally, we could put this in our calculator and find the graph. And so do that. So we need to choose a graph from one of the 4 that's given. Notice I have an x through the first one. I know that can't be it because it has a 0 at -4, and -4 is not in our list. It can't be this graph because this one shows a 0 at -4, and -4 is not in our list. Now the last 2 graphs actually show those 4 zeros, so we need to pick which one based on the graph. And if you notice, if you graphed it, then it can't be this one on the bottom left because of this high point right here. That's not what the graph shows. The graph shows that we have this dip down here. So this would be our final graph. Okay, so what else is happening next? So I'll just end this video here and pick up with this problem on the next one.